And now we shall speak about our kids, about our guts. And first of all, I would like to remind you, how many microbiologists in this hall? Tell me, please. Can you just raise a hand? Well, 2, okay, 3, 4, perfect. I'm the 5, the 5th. Before the Human Microbiome Project, we didn't have our own organ to explore, because gynecologists, they have their own organs, pulmonologists too, but now we know that human microbiome is another and very important extracorporeal organ in our body, and it's very important for our health. And the thing is that up to 70–80% of all microbiome is presented in our gut. Of course, we know all the classic functions of gut microbiota. First of all, it helps us to digest the food we eat. It has a lot of protective functions. It trains our immune system. It has barrier functions. And in general, gut microbiome could be viewed as a shield or an army which protects us against pathogenic invaders which could come with food or beverages we consume. But I would like to ask you the questions. Who really control us? Our brains, or maybe gut microbiota? Today I shall try to get some answers to this question in my report. The thing is that gut microbes communicate with our brains. First of all, they produce some neuroactive molecules, and these molecules send messages to brain in 2 ways. Directly through vagus and indirectly by modulating the immune system. And so you can see that a diverse community of gut bacteria produce a cocktail of different molecules, and together they have a powerful ability to shape our nervous system and even to influence our behavior. Of course, let's discuss the early stages of gut colonization and how a baby's microbiome is built. The process happens in clear stages, and it, of course, starts with the mother. The maternal microbiome is very important because it's the primary source of baby's first microbes. However, mother's own microbiota is unique and is shaped by many factors like genetics, environment, diet, and so on. Today we talk about the so-called 1,000 days windows of opportunity. And this window of opportunity starts at conception and is a time of the first 2 years of life. And this is a critical time when we can possibly influence babies' microbiome as a foundation of their lifelong health. The expert opinion is here. The experts who are gathering every 2–3 years in one of European capitals characterized the most important driving forces of gut microbiota for kids, of course. The first one is the gestation age at birth. The second, the mode of delivery, then early breastfeeding, the feeding mode in general at the first year of life, and antibiotics. And scientists still discuss whether other factors are also important. They are important, we just do not know for sure their impact on gut microbiota. But maternal microbiota, environmental factors, family lifestyle, the pets who have dogs at home. I had, now I do not. Dogs are beneficial for gut microbiota of kids, you know, as well as siblings and big families. It's all good for a diverse gut microbiota. But of course, there are some factors which could damage gut microbiota in this early period, and antibiotics are among them. I shall remind again that antibiotics save lives, but still, when we prescribe antibiotics without need, we can damage gut microbiota, and you can see that when we prescribe antibiotics in the first 6 months of life, we can observe the decreased abundance of bifidobacterium up to 10-year-old age. What is even more interesting, that the boys are suffering more from antibiotics in this period because the significant deterioration of weight and height gain was observed for them. It was not true for girls. But when we prescribe antibiotics after this age, from 6 months up to 6 years, most probably we shall see the significantly higher body mass in these kids throughout the study period, and it was true both for girls and for boys. So as you can see, a lot of diseases are associated nowadays with the disturbance of gut microbiota, starting with atopies in the first year of their life, then allergies in early childhood, inflammatory bowel disease in older age, obesity. Gut microbiota is associated with hyperlipidemia and type 2 diabetes. And what is more important, that it's associated with autism spectrum disorders as well. You know, when I was preparing this presentation, I was looking for some picture, and do you know what I was looking for in Google? I asked for autistic mouth. So this is the one, the autistic mouth. And really, it was shown that in germ-free animals, we see the reduced social interaction, the altered brain chemistry and structure, and if we give them probiotics, we can see the reduced anxiety and depression-like types of behavior even in mouse. You know, mouth is our big friend, really, despite its small size, because it helps us to understand the interaction between gut microbiota and our central nervous system. Now, about bacteria, which constitute the gut microbiota. Dominant gut microbiota phyla are Bacillota, Bacteroidota, Actinomycetota, and Pseudomonadota. You can see them in the slide. And Bacillota and Bacteroidota represented up to 90% of all gut microbiota. Bacillota phylum is composed of more than 200 different genera, such as Lactobacillus, Clostridium, Enterococcus, and so on. And Actinomycetota are mostly presented by Bifidobacterium, while Pseudomonadota is the source of some life-threatening pathogens, the representatives of Enterobacterialis genera. If we shall speak about their functions, what is really interesting, practically all these bacteria are able to disintegrate complex carbohydrate. So this degradation of complex carbohydrate is essential for us because we can't otherwise digest them. What is more interesting, that many of them produce very important anti-inflammatory molecules, short-chain fatty acids, a lot of neuromediators, some vitamins, also essential for us. And they may perform the same functions sometimes. And if you will ask why so many different bacteria are doing the same things, I shall answer you that this diversity helps our stability. The diversity of normal microbiota is necessary for stable normal biota, for normal microbiota of gut. But then there are other less common phyla which are also presented in gut microbiota. First, we have Fusobacteriota. This group is often a warning sign because it's associated with inflammation. And one specific species, Fusobacterium nucleatum, is considered an early marker of colon cancer, what is also important. On the other hand, we have some very important markers of gut health like Ackermann's eosinophila or Faecalibacterium prausnitzii. They are absolutely necessary. And what is even more important, that we have archaeas in gut microbiota, because all microbial activity produces hydrogen gas. And to keep the system running smoothly, without extra gas in their bowels, other bacteria must consume these hydrogens. And so not bacteria, but archaeas are helping us in this process. So Methanobrevibacter smithii, the representatives of archaea, is presented in our guts. But what complaints do patients and do parents most often address to a pediatrician and gastroenterologist? You can see them on the slide, and well, I wouldn't repeat them because you know them very well. And of course, not only signs of some gastroenterological disorder brings our patients to doctor, but also it could be some neurological disorders as well. That's why we need the reliable tests for laboratory diagnosis of gut dysbiosis, which are based on fundamental research we discussed just now. And while cultures are the historical foundation, frankly speaking, modern diagnostics are moving towards DNA-based methods. Of course, NGS is a perfect basis for scientific research, but for clinical usage, we prefer real-time PCR. And ENTEROFLOR Kiddy, so you have heard about this test, a test which was designed specifically for children from the birth up to 14 years. It allows us to determine up to 99% of all representatives of gut microbiota. But do you really want a list of 200, 300 bacteria taxa? No, of course. That is why we have just 43 key parameters, which include all this microbial diversity. And it's of course fast because it's real-time PCR. In my lab, it takes not more than 2.5 hours to get the results. ENTEROFLOR Kiddy reagent kit allow us to detect bacterial DNA belonging to bacteria of Bacillota, Pseudomonadota, Bacteroidota, Actinomycetota, Fusobacteriota, Verruca microbiota, and Archaeota phyla, including Candida fungi. Also, we can detect genes of methicillin resistance of Staphylococcus species, Clostridioides difficile with its enterotoxins A and B genes, And we can detect Streptococcus agalactia, which is important for newborn kids, of course, with the invasiveness marker gene as a rare tool. Now I would like to show you the exact phyla and genera which are determined by this test. Normal microbiota is determined by phyla. Phyla Actina mycetota is presented by bifidobacteria, including the so-called metabolically active child species and metabolically active adult species and Coriobaccteria. Then phylum Bacillota is presented by Clostridium leptum group, Dialista Lincella Megasphaera velanella, Faecalibacterium prausnitzii is detected, Lachmus pericytata, and so on. Phylum Bacteroidota is presented by Alistipes, Bacteroides, Butyricimonas, Parobacteroides, and Privatella. And also other very important markers, which are the markers of health microbiota present in this test. Now, about opportunistic microorganisms, markers of pathogenicity and resistance, which are also could be detected by the test, and you have seen the examples in the previous report. Clostridium difficile group and Clostridium perfringens group and Clostridioides difficile. Do not mix these taxa because they are different. The cause of pseudomembranosus enterocolitis is Clostridioides difficile with these genes of toxigenesis. Then, of course, Enterobacterialis and Escherichia coli, Enterococcus, and some not so well known to us taxa like Rhizopilotrichiaceae, Fusobacteriaceae, Peptoniphylaceae. All of them are the markers of inflammation in gut microbiota. And of course, Staphylococcus aureus, Streptococcus agalactia, and Candida species with Candida albicans. ENTEROFLOR Kiddy is recommended when it's necessary to determine the qualitative and quantitative composition of gut microbiota. And the target patient groups are children under 14, patients of different specialists, pediatricians, gastroenterologists, immunologists, endocrinologists, neurologists, nutritionists, well, whatever, and even for caring parents. For those who are always thinking that something is not right with their kids. What is really good, because it's real-time PCR, it's very easy to obtain the material, to store it, and to transfer to the laboratory. I think all of you who have kids, you know, when in all the times you have to bring feces for the analysis, for bacteriological analysis, then you have to get these samples in the morning, then you are running to the lab, and usually your baby does not want to give you any sample in the morning. As for ENTEROFLOR kit, it's not like this, because you can obtain the material at any time of the day. Just the parents could store it at the refrigerator. I suggest not more than for a day, and then to bring to the nearest laboratory is very convenient. And the interpretation of the test is different. It's different from the well-known cultures to us, because of course we have some very well-known characteristics from this test, some very well-known indicators like the presence of lactobacilli or bifidobacteria. So, наработался микрофон. So it's overworked, I think. Thank you. Okay. But we can get some very important information which is new for us, like the proportion of normal microbiota. It's impossible because this is the quantitative test, and we can calculate the proportion of each group of microorganisms comparing to total bacterial load. We can define the normal microbiota diversity. You remember that I told you that the diversity is very important. The more, the better. The more representatives of normal microbiota we define, the better the state of microbiome in general. And some additional information like the presence of adult and kids, child species of bifidobacteria. And here you can see the example. You have seen one. This is the example of the material of a 4-month-old girl. And this is not normal. I shall show you the conclusion of the test and what is really good. For those who are in a hurry, I mean the doctors who are in a hurry, you can just read them the first page in the right upper angle. You can see the conclusion of the test. But of course, if you would like to get some more information, you will look through the second page of the test. And here you can see this conclusion for the test for this girl. You can see that the proportion of normal microbiota is reduced. This is the unknown parameter for us. You can see also that the taxonomic diversity of normal microbiota here is within the normal range, and so on. So that's how it looks in reality. We can analyze the samples from newborn babies, those who are under 10 days of age, and it will be interpreted differently. Because the analysis of meconium is different in this test. And you have to keep in mind all the time that the reference intervals for this test, they are specific for every age of the child, because the composition of gut microbiota changes a lot, especially during the first year, and I shall prove it to you. Now I would like to share with you the results of our pilot study with ENTEROFLOR Kiddy test when we analyzed gut microbiota development in infants in the babies of first year of life. So we analyzed almost 700 samples of kids between 1 day and 12 months of age. You can see the exclusion criteria here in this slide, and you can see how many babies were in every group. So we performed ENTEROFLOR Kiddy for all of them, and here you can see the dynamics of gut microbiota diversity and quantity of microorganisms in the first year of life. You can see that at the very beginning, really there is no bacteria practically, just in some samples. And then the number of microbial groups increasing through the first year of life. And the total bacterial load also increasing the first year, especially the first few months, and that we can define it on the same level practically. And excuse me. And here you can see the proportion of major and subdominant phyla in gut microbiota also throughout the first year of life. And you can see that they are changing differently for each age at the first year of life. You can see the specific bar on these pictures. And if actinomycetota is prevalent in the first few months, then bacillota will be prevalent, for example, at the end of the first year of life. I wouldn't pay much attention now to this slide because it's rather complicated, but anyway, it shows that every other month on the first year of life, the microbiota is really different, and we have to take it into account. And so our preliminary conclusions, of course, allowed us to recommend this test, not only for diagnosis of some imbalance of gut microbiota, but also for monitoring the condition of gut microbiota through the life of our kids. And here I would like to share with you the results of research of our Bulgarian colleagues. who analyzed the diversity of bifidobacterium and lactobacillus species in healthy infants, again, under 6 months of life. And also you can see that they are different. It's different from the results we got with cultures before time, you know, absolutely different. And at the end of my report, I would like also to share the preliminary results of our other research, where we analyzed microbiota, gut microbiota in preschool children with neurodevelopmental disorders. So we managed to get material from 69 kids who were going to the special kindergarten for kids with neurodevelopmental disorders. They were different types of disorders, but still you can see that all of them were of age from 4 to 7, so it's really preschool age. And as a control group, we took healthy children who were going to the ordinary kindergarten, and they did not have any signs or symptoms of neurodevelopmental disorders. And all of them, ENTEROFLOR Kiddy test was performed. First of all, I would like to, just a moment, show you the detection frequency of microbial groups when we use this test. The red bars are healthy kids. The green are those with neurodevelopmental disorders. And you can see that even the frequency of determination of different groups was different. So they were different. And the most important changes were detected for Pseudomonas desulfovibrio staphylococcus. Their determination was increased, while Lactococcus, Lactis, Clostridium, and Akkermansia muciniphila, one of the markers of healthy microbiota, the detection rate was decreased. Then we analyzed total bacterial load, taxonomic diversity, and the Bacillotobacterioidota ratio in those two groups of samples, but no real differences we have obtained. So next we decided to look at the abundance and proportion of exact phyla in those two groups. And you can see that the abundance of some representatives and proportion of Actinomycetota was different in healthy children and in those with neurodevelopmental disorders. The most important differences, were for Coriobateriota abundance, it was increased, while the proportion of adult bifidobacteria and the proportion of Bifidobacterium catenellatum was decreased. Next phyla we analyzed, of course, was Bacillota. You can see that a lot of bacteria belong to Bacillota phyla in this test, and a lot of significant differences were obtained, and you can see the most important, the abundance and proportion of Lactobacillus, Lactobacillacea, Lactococcus lactis, and Streptococcus was decreased, while the abundance and proportion of Staphylococcus was increased. And the next one is very interesting because it's Bacteroidota. Bacteroidota also showed us a lot of differences between those two groups. And the most important were associated with Prevotella species. Just look at the difference. The abundance and proportion of Prevotella species was extremely different, and it was higher in kids with neurodevelopmental disorders. It was a question we asked ourselves, why, and decided to make such a scheme which will maybe give an answer, because in general Prevotella is good for gut microbiota, but I guess everything depends on their quantity. When we have too much Prevotella, most probably we are dealing with some kind of dysbiosis, which is not good for neurodevelopment and for our behavior and health as well. And now at the end, I would like to show you how important is gut microbiota for mental health, for cognitive functions of kids, and how it's associated with the food they obtain. Look, this is a kid, this is a 9-month-old boy. We did not find a lot of very important representatives of Bacteroidota and other markers of healthy gut, which have to be founded at this age. Bacteroidota are absent. Akkermansia, Mucinifila, the sulfovibria, Methanobrevibacter are absent. But look at medical history of this baby. Term delivery, fine. Exclusive breastfeeding, up to 9 months. Only breastfeeding. So, no adult food. That is why no Bacteroidota here. And what the mother is speaking, she tells that the baby is restless, poor sleep quality, and of course they were just recommended to feed the baby with the proper food. Here you can see this group. And the other example, also very similar, because we did not find any practically Bacteroidota here. Staphylococcus aureus was detected, the elevated levels of Enterococcus, and also you can see medical history of this baby. They have they have the diagnosis up at his age, and he refused to chew. He prepares purified food. Again, the problems with feeding. And of course, despite medical treatment, they were recommended to change their diet. So the conclusion is the following. The gut microbiota of preschool children with autism spectrum disorders and other neurodevelopmental disorders exhibit the reduced quantity of and proportion of some very important representatives of normal biota. Bifidobacteria, Lactobacillus, Streptococcus, and with concurrent significant increase in quantity and proportion of Prevotella species. So at the end, let me again repeat the advantages of the ENTEROFLOR Kiddy test, because it allows us to detect 43 markers detecting 99% of all gut microbiota, ready within hours, age-specific analysis, and very practical storage. So it's very easy to implement this test in our clinics and our laboratories. Thank you very much.